So as usual, what I'm going to do, I'm going to import the normal libraries. So Seaborn, Pandas, NumPy, PyPlot, and percentage matplotlib inline. So let's run this and import all the necessary libraries. So yes, we imported. And here, as I mentioned yesterday, we have many data sets available in the Seaborn. So what we are going to do, we are going to load tips data set, right? So same method I'm going to use SNS and this load underscore data set. So I'm going to use a tips data set, right? So this tips data set is basically related to tips where customers give some tips to the servers or bartenders or waiters, whatever you can call. So if they like the service, they will give some tips, right? Or if they like the food, they will give a tips or things like that. So especially in the US and all, more as I said that 99% of customers will give a tips whenever they visit any restaurant or a bar or things like that. All right, hotels. So they have collected some data from one of the restaurant, and they have collected and documented and made that documents, or I would say this data available for everyone. All right. So that data set we are going to use. So whole thing I'm going to store in a tips, one of the variable I can call, and I will just check the data here. Right. So let's execute this. So this is how the data looks like, right? So there are, since I used a tail method, so we have a 243 or 244 records, right? Because it starts from 0. 244 rows we have. So now let's try to understand what and all we have with us, all right? The column names. So this total bill is basically what is how much a customer made a bill, right? Whenever he visit any restaurant. So basically total bill, right? The whatever order, irrespective of that. So how much his bill amount is. So this is basically talks about that. So everything is in dollar base, not in the rupees. Okay. And this is a tip. How much a tip is given to the servers or the bartenders, right? So, and the male or a female who paid the bill. So here it is not that matters because I can go with friends can be male or a female, right? So whoever pays bill, their gender is basically highlighted here. So it is not going to worry much, I would say. Yes, but still they have documented this. And whether the customer is a smoker or not a smoker, right? Yes or no. And on which day they visited that restaurant. Saturday, a Thursday, or a Sunday, Friday, right? So those dates also noted down. And which time? Is it during the lunch time or dinner time? And size of the customers, like 3 people, 2 people group, or a 5 people group, or 3, or a 2, or a 1, or a 6. So group of people, right? So I can go with my wife and 2 kids and 2, guardians or parents. So total size is say 8. So 8 people group. So we can go with you and okay, your friend, so 2 people. So that group is also noted down. We call it as a size, right? This is basically what. So let's try to understand in one sentence how to interpret whole data here. This row. A customer made a bill of $29.03, and after that he paid a tip of $5.92, and the customer gender is male, and he was not a smoker, and he visited restaurant on Saturday during dinner time, and he went with another 2 people, right? Total 3. So this is how you can interpret this whole data. Similarly, for this is for next customer, next, and next. Right? They have collected overall 244 visits data. Right? So this is how you can interpret this. Now let's try to talk about plotting techniques. So rel plot. rel plot. What is rel plot? Rel plot is relational plot, right? Relational plot. So what we are trying to achieve here? We are trying to achieve something. Is there any relation between one column to another column? So in this case, is there any relation between total bill and a tip? Right? So I'm trying to see that is my tip depends upon the total bill, or is there is no relation? But just think, right? So we'll always go to a restaurant, and depending upon the total bill what we make, based on that we usually give the tip. Let's say that if I visit Starbucks, right? Starbucks, and or a cafe coffee day, CCD, whatever. If I take a coffee and which cost me 100 rupees, right? So I don't give him a tip of 50 rupees or 30 rupees or 70 rupees or 60. We tend to give around 10 rupees. So here basically we don't give a tips in a Starbucks or a CCD, but yeah, if you visit let's say any famous restaurant or anything, right? So if you make a bill of 500 rupees, right? Make a 500 rupees bill, then total bill. So you will not give a 200 rupees tip, right? We'll try to give around 50 rupees or around that range. But if you go with your friends and make a bill of 5,000 rupees, so obviously we tend to give more than 100 or 200 rupees because your total bill is more, right? So that's the human tendency, and most of the restaurants they will charge like a service charge if a group of 4 people or 5 people. In US, I think 5 people if you are visiting in a group, and the 5 people, so they don't ask for a tip, or anyway nobody will ask, but by default they will add a service tax, right? So which is a 9% or a 10%. It all depends upon the restaurant because the government will not have any control on that. So it's individually, basically restaurant dependent. So basically we are trying to understand, is the tip dependent on the total bill or not? So how will I identify that? So I'm going to check this, plot this relational plot, right? So I'm going to use it. So Seaborn dot relational plot or a rel plot. So whenever I plot a rel plot, I'm trying to find the relation. When I try to find the relation, I need at least 2 variables data. So I'm taking a X as a total bill, Y is a tip, and I'm going to pass the whole data set. So in this data set, take a X and Y and plot the bill, the plot. Okay, so let's look into this. So basically here we can see that, okay, let's interpret this. Okay, so this is a total bill and this is a tip. So let's try to understand if my total bill is $10. So the tips is generally what customers give around this range. Like say this is going to be $1 and this is a $2, right? So most of the time people will give $2 tip if they make a $10 bill. If as and when my total bill is going to increase, so customers tend to pay more and more tip, right? Some kind of a relation we can see here, right? If a customer is making a bill of a total bill is $50, and you see that most of the time the range is in this range, $6 or $7. I think this guy is maybe somewhere around $45 somewhere, right? So this, if I talk about a $50, so that particular person paid around a $10 tip. So this kind of a relation I will be able to establish using a relational plot. Right? If there is no relation, maybe my data will be scattered in somewhere here and there. And it is moreover very close to scatter plot. Very close to scatter plot. And the difference between scatter and all relational plot, you will find that you keep your cursor inside the bracket and press Shift Tab. Press Shift Tab. Here you will see all the options. So these options are basically for a designing purpose and all. We will see some of them, whichever is necessary for us. All right. Otherwise, this is more of a for the designing and all, which we are really not interested in the design. We are not going to design anything here, right? So we always need only simple data to analyze it. More colors, more designs will distract our analysis, right? So we don't want that. Fine. So very simple relational plot, right? So what we will do, we'll try to extend our discussion on the relation plot with few extra parameters. All right. So now let's check how many smokers visited and how many non-smokers visited. How do I get? So this is data set and select the smoker column dot value underscore counts parenthesis, open and close. So what it is going to give, it is going to give me the count of smokers and non-smokers, right? Whenever you want to find any particular category count, so you can use a value underscore counts. No is one category, yes is one category. You will be able to find the total number in this particular category and in this particular. So we'll try to do some kind of analysis. So we wanted to show you how we can identify the total counts of individual group or a category. So now what we will do, we'll use this sns.rel plot, cborn.relational plot. X is my total bill, Y is a tip. And this is my data set. Here I'm using two parameters. One is a hue, another one is style. Hue I'm keeping a smoker and style I'm keeping a time. So I will explain that, right? So I cannot put you in an imagination word, right? So it's better to plot it and interpret this. You'll get to know yourself. So now, this is basically, again, relational plot. Here we can individually identify the data. Like, I say hue equal to smoker. What this guy will do, this guy will color code. Color code. So in smoker, we have a yes and no, right? So S will be color coded with one color and no will be in another color. So S is blue, no is orange. So basically it will differentiate yes and no with some colors. So that is what this particular parameter will do. And I have a style. What style does? Style is a time. So it is going to give a different style, different design for different times. Like a lunch is designed, or the style of lunch is circle, and a dinner style is basically cross. So this will help us to identify particular customers. Like, let's try to understand this. I hope it is visible to everyone. This is a blue and it is a cross mark, right? This is a cross mark. So what is a cross? Cross is a dinner. And which color it is? It is yes. It means that a customer who visited, who made a bill of a total bill of $50, he or she, that group, visited during dinner time and they were smokers. They were smokers. So this idea, this interpretation I can make. If I talk about this circle, so this is an orange, right? Orange. So orange is what? Orange is basically no, means he is non-smoker or she is non-smoker. And what is this design or the style? This is basically lunch, lunchtime. A group of people visited during the lunchtime who were non-smokers and they made a bill around $30 or $32. So this way I will be able to interpret what kind of customers they were, during which time they visited, So these are all basically, we need this data to analyze, right? So we can basically analyze this. All right. Okay, so then we'll see some more thing here. Relational plot, X data, a Y data, total data set I'm passing here, and I'm giving a size equal to size. Size equal to size. This is a new one more parameter. Here we used a hue and a style. So here I'm using a size parameter. And in that I'm passing this column name. Every column will be picked from this data. You don't need to worry about it. You just need to make sure you have to pass the data set. And make sure your column names are coded properly. So let's understand this size. So here you can see it started from 0, which is supposed to be at least 1, right? 0 means nobody visited, right? So it is increasing the size of these dots or the circles, dark circles here, right? If the size is small, it means that the group of people or maybe 1 or a 2. If as and when it is increasing, so it means that yes, there are more and more people in the group. If I take this very tiny dot, so maybe only one person visited, maybe he went for a coffee or just to have one snack bar or something like that, right? So here it is a little bigger. So this is basically going to give me some indication that I don't need to look into how many and all. So this is the idea to interpret the size of the group is getting bigger and bigger if the total bill is getting bigger and bigger, right? So that is the interpretation, the analysis we can make. I'm sure that it is very difficult, even for me also it is difficult. How can we interpret this circle is a 3 or a 4? How can we interpret this is a 2 or a 3? It is difficult, yeah, but yeah, that's how it is, right? So here we are trying to understand what is size. Size is it is going to give. Maybe if we have a different data set, so that time maybe you will be able to make it out, right? So here we have a very close encounters, I would say, when it comes to group of people. So maybe we'll have 1, 2, 3, 4, 5, and 6. So they are very close to each other, right? It is very difficult to make out which dot is belongs to which group of people. All right. Maybe you can try with different group and all. All right. Now let's look into one more. Okay. So this is basically what relational plot and size and all. How about the size in this plot, right? Size, it's up to you. So as long as you are able to interpret this graph, so we really don't care about the size. What happens even if it is a bigger one? Is my analysis going to change? No, right? So if you want to extend this size and all, yes, you can check this any of the parameters where you can increase the plot size. If not, if it is not there, how we are going to allocate that space, fixed size, that I will explain that if it is not available in the parameter, right? That situation we will encounter in the upcoming classes, right? So with the default plot, I will be able to make out. So I don't need any a larger size to see this data. Fine. So simple plot, relational plot. And next one is scatter plot. This is the same scatter only. So what we have seen, not much of a difference. Here you may get extra parameters to color code and design and all. Otherwise, the analysis wise and all, it's not going to change anything. So how I'm going to write? Cbar dot scatter plot. Scatter plot. In the earlier techniques, we used to write only scatter. Here we are writing a scatter plot. Basically, we are adding a plot to it. Relational plot, scatter plot, line plot. All right. So let's execute this. It's almost same only. It's not going to change. Here, your size is coming inside the box, inside this particular frame. Otherwise, it's just like a relational plot. Just like a relational plot. Not much of a difference. So if you understand one plotting technique, so almost all are on the same line. Almost all. It's just that they have come up with different names with some extra parameters, which for us it is not needed. It is for those who created dashboards, who basically need to design the graphs and all. For them it matters. For a data scientist, we really don't care about the color and things like that. Right? Now let's look into this line plot. So this is a line plot. So how it works? So for a $10 bill, suppose say it's a $3 tip. I'm just starting from here, right? If $11 bill, what is the tip? So there will be like a bill amount will be $10, 1 cent, $10, 2 cent, $10, 50 cent. So those are all data. Those are all the total bills. For each bill, there will be a tip. So it will be, it looks like this. Let's say that it is looking like this. Okay. So with line plot, what it is going to do, it is going to connect all those dots. That's all it is going to do. I will connect all these dots wherever it is. Go here and come back, and there is a tip, connect this, and yes, this is how it is going to plot. Connect all the dots, all the tips data. If you want to visualize your data in this fashion, you can use a line plot. All right.